Welcome back to Introduction to Making Schematics and PCBs with KiCad. This is part 3 where I'll teach you about how to lay out the PCB. So let's jump in. First we need to start KiCad. Again, for my students, go to the R drive, go into KiCad, click on the KiCad shortcut. Once you start KiCad, the Project Manager window opens up, and it'll show the SMD adjustable LED circuit that we're working on under the recent projects. So I'm going to double click on the schematic editor from the SMD adjustable LED, and it opens up the schematic again. Again, use the center scroll wheel on your mouse to zoom in. You can use the center scroll wheel, just push and hold to drag it around to where you want to see it. Now before we lay out the PCB, I want to show you the workflow up here across the top. We could create, delete, or edit symbols, but we have symbols that we need. We don't need to mess with the symbol libraries. We pulled the symbols we needed out of those libraries. Didn't need to create, delete, or edit any footprints. The next thing is to fill in the schematic symbol reference designators. If we click on that, it pops up with our Annotate Schematic window. We can say, yeah, we want to do the entire schematic and keep the existing annotations. This is to check and see in case you didn't annotate some of your symbols. But we've annotated everything, so it says annotation complete. So now I can close that window and move to the next window, which is the electrical rules check. So let's click on that. We want it to show any errors, any warnings, so we'll run the ERC, electrical rules check. It says it's done, but there's an error, pin not connected, and it tells us where that is and shows on the schematic this red arrow. So I could delete all the markers, or I can close that window and then click on that marker and then just hit the delete key on my keyboard. But I need to take care of that pin right there. The computer doesn't know what to do with that pin. It says it's not connected to anything. Now I could run a wire to ground, or I can go over here to the add no connection flag. I'll click on that and then drag it over and place it on that pin, and now the computer knows there's no connection to that pin. I can click on the cursor arrow to deselect that, and then let's rerun our electrical rules check one more time. And no errors or warnings are detected. 0 each. Green lights is a good thing. So we'll close that and know that now we can export our schematic. I'm not going to simulate this circuit in SPICE, but I will run a footprint assignment tool. Now, we've previously assigned footprints. This is where if you missed doing that, you'll have time to do that. Now, it takes a while to load the footprint libraries, and then it pops up with all of the footprint libraries here, the assigned footprints. You can resize these windows. If I click on this edge and drag it over, I can see the entire things that I've assigned. I only have 4 components. All 4 have footprints assigned. If there were some that were missing, it would show the symbol reference, and then it would show that it doesn't have a footprint assigned. So you could go through and assign that then. So I'll click OK since we're done with the footprint assignments. And I'm going to go to the next thing is open the PCB in the board editor. And it comes up with this dark background, bright pink purple lines to show the schematic, and it has all of my options here. On the right are the different layers of the board, some of the tools that I can use, more tools and dimensions to edit on the left, and across the top is my workflow. I'm going to start with update the PCB with changes made to schematic. So I'll click on that, and it does have pre-selected replace footprints with those specified in the schematic. I want that, so let's update the PCB. It gives me 0 warnings, 0 errors, so I'm going to close that, and here it shows the footprints of all the components I need. So I'm going to place them in the middle of my schematic, and then scroll the zoom wheel to zoom in. It shows lines showing which pads should be connected to each other. So I'll click off somewhere, and at this point you can click and drag the components to where they need to be. I'm going to move resistor 1, you highlight the whole thing, see how it drags the lines to show which pads should be connected. I could also hit the R key to rotate it, click somewhere off of it to deselect, select another, click and move, highlighting my diode, my LED, and there's my entire schematic. Now that we've gotten the preliminary layout for our PCB, let's take care of a couple of things that need to be done. Let's zoom into the title block and add a title to our project. Double click on the title and it comes up. We'll put today's issue date. We can change that later. I'm going to put as the title same as the schematic, and add myself as the author. The next thing before moving any further is I need to know the dimensions of my board before I can make sure all the parts fit where I want them to on the board. This is a picture of the board that I already have in stock. This printed circuit board material is fiberglass. It's sold as 2" by 3". It's actually about 2 1/4 by 3 1/4 inches, but when you look at the millimeters, it looks to be about 82 or 83 millimeters by 57 millimeters. So I'm going to put those dimensions in as my board size. In order to put the board size, on the right side, click on the edge cuts layer, and then click on the draw line. You can pick anywhere on the board to start your line, so I'll just pick this spot here, click, and then drag over a ways, click again, drag down, click again, and back up in approximately a rectangle, and it'll seal that. The next thing to do, hover over the first line and use the hotkey E on the keyboard. It'll tell you your starting point and ending point of the line. I'm going to round the X starting point to 122 and the Y to 74. Now if I know my length of my line is 82 millimeters, then I'm going to add 82 millimeters to 122 and change the end point to 204. The Y is going to be the same, 74. That extends the length of my line to the size of my board. Then I'm going to hover over the next line, hotkey E. This time I want the X to stay at 122 for both points. The Y, I'm going to start at 74 and end adding 57 millimeters to that at 131. The next line, and now I've finished the dimensions of my board. Putting the board dimensions down gives me a better feel for how I want to orient my footprints, how much size I'm going to need. I don't want to be right near the edge, but I can rearrange the layout to fit the size of the board. Next, make sure you click back on the front copper layer, and I want to rotate the whole thing. So I'm going to highlight the whole layout and then hit the hotkey R to rotate. Then I can click and drag it to wherever I want. I want to give myself a little bit of room away from the edge of the board. If I want to rotate the lettering so that I can see it better, click on the word and hit rotate, the hotkey R again, you can rotate that. So again, just the lettering will rotate. I can click and move those. Just move them to where it's easy for you to keep track of them. The next step is to place the tracks connecting the pads that need to be connected. You go up here, it says the track uses the net class width, or you can edit some predefined sizes. We'll just go with the default for now. Go over to the right side, click on the Route Tracks button. Then you can start placing tracks. I'm going to start with the terminal 1 of the battery and drag over to there. If you need to zoom in, you can double click on any of the tracks and it'll give you the track width. Let's say I want to use a little wider track, even double, so I can go 0.5 millimeters. The other way to do that is to edit the predefined sizes. You can add different sizes here. So if I want to add, and maybe I'll add another one. Then you can go up and select those track sizes here. So if I wanted to highlight a track and delete it, and I've selected my 0.8, select my track again, and there it is. Now if that's too thick, go back and select a different track size. So again, you can double click on any of the tracks and change the sizes, or delete them. Say I want to delete this, highlight and delete the track, click add again. You can reroute your tracks if you need to. And that's how you connect all your components together. Now we're trying to do a very simple PCB design. Everything is on one side. There's no bottom copper layer with tracks on the other side. If you do have through-hole components or have tracks on the other side that you need to place, you would use what are called vias. We'll do that in a later video and explain how to do more complicated boards then. The last step here is to show the design rules checker window. So I'm going to check to make sure everything should work in my design. It's going to show errors and warnings if I don't have things connected the way they should be. So I'm going to run the design rules checker. It doesn't find any errors or warnings. Watch what happens if there is a problem, if I delete a trace, for example. Let's try again. Run the design rules checker. It will recognize, hey, there's some unconnected areas here. It's going to show me, flags this. It says, hey, it's not connected to anything else. So I'm going to delete all those markers, close that, fix the track, and then run that design rules checker again. No problems, 0 errors, 0 warnings. So I'm going to close that, and it says everything should work the way it's intended to. And this circuit should work. Now we're done with the layout of the PCB. The next step is exporting these files so they can be printed. Either printed at a board house or in-house on our own machine. In the next video, I'll show you how to generate the files for printing your board. Thanks for joining me for this episode, and we'll see you in the next one.